sound. So, what was I saying? I was saying that if you're watching the stream, you're probably well aware that Defcon Quals was this past weekend. And I was saying, so Defcon is a big conference in Vegas every year, usually the first weekend in August, the last weekend in July, sometime that time frame. I think this is year 26 of them hosting it. And for the past, I don't remember when, I think it's been since Defcon 8, they've been running a CTF there. And typically it is especially the, what gets called the current era of the CTF. I know, I'm explaining a little bit, and it's probably not necessary for most of the people watching, but for the current era, it's been a attack and defend CTF with a qualifier for it in the form of a Jeopardy-style online CTF. And the qualifiers are usually in late May or early June. This year they were late April. But again, the most important thing is that it happened this past weekend, and one thing that was really interesting about this year is that it was entirely binary focused. In previous years, they've had some web challenges, some crypto things, some reversing, things like that. This year, there was none of that. Their web challenge was a Ada web server that was a binary pwnable. I think they did the same thing last year, too. The only web service they had was an exploitable web server. But in any case, the CTF was this past weekend. Hopefully you got a chance to play if you are interested in that kind of stuff. There were tons of good challenges, and for the most part, it was a ton of fun. And as I imagine a lot of people who are watching know, the teams that so there's a little bit of question right now about exactly who is going to qualify, because it's a little bit up in the air due to the fact that they're going to have 15 teams at finals, 8 of which I believe are already qualified. One of them qualifies from OCTF finals, and the rest come from this event. And on top of that, things like Plaid Parliament Opponing are already qualified. Defcore is already qualified, I believe. Samurai might already be qualified. I think Eat, Sleep, Pwn, Repeat might be qualified. In any case, a lot of these teams are already qualified. There's going to be some complications. I'm glad it's not my problem to figure out who exactly is qualified and who isn't. So, as far as this weekend goes, if anybody has any requests, so I have just very recently pushed to, of course I'm not logged in here, GitHub the challenges that I actually solved during competition. There's a handful of them. They're all pwnables and reversing stuff. But rather than what we've been doing in the past, where I've gone through, went through and talked about solutions to challenges I solved during the event, this time I thought it'd be a little bit interesting to take a look at some challenges that I didn't look at then. In particular, the magic challenge. So that's one of the automated exploitation challenges that have started to become a little bit popular. Basically, the idea is, well, here we go. So they gave us a tarball, which had 200 individual binaries. And the idea was that you needed to create a solution of some sort for all of these, and then you connected to their network service. They told you, I don't actually know how many you had to solve on the network service, but you had to solve some number of them. If you solved like 100 of them or something, it'd give you a flag back. The idea is that the only way you could do that is if it was done automatically, if you wrote some sort of an automated exploitation script. Now, that's how they did it last year because of CGC, the Cyber Grand Challenge. They had an entire category of those, and Trail of Bits has a really good blog post on it about the Trail of Bits 1,000 cuts. 2,000 cuts. But they've got a good post here about it, them solving it last year, which was, there were 2,000 binaries in which you had to find various types of bugs, I think. But you had to actually do it automatically and throw exploits at whatever version they told you it was going to be. This year was a little bit different. I believe they were all crack me's. So instead of having to exploit a service, you had to supply the password or whatever the thing that you had to supply was. And if you did, you had a flag. You had to solve some number of them. So the reason we're doing these on stream tonight is because I didn't get a chance to look at them during the competition. I believe these opened up Saturday night, was when the first of them opened up. And at that point, I was looking at, which of these was it? I think it was Propto. It was either Propto or Leo that I spent all night. I have some timestamps for some of these. So I think it was, maybe it was Badint. As you can see, my commit messages are a little bit not so useful from the event. But I think I spent all evening on Badint while one of my teammates went through and solved the crack me's. So I didn't actually get a chance to look at basically any of them during the competition, and I'd like to look at them now. So that's what we're all going to do. However, if you'll give me just a second, I will be right back. I'm going to go grab a drink so I don't lose my voice again. So, where was I? Yes, sorry about that. I had to run away for a second and grab a little bit of something to drink for when my voice goes out. So, what I was saying was that we have 200 binaries here, which are crack me's from the first version of the challenge. So we're going to go through and solve these because one of my teammates so selfishly solved them while I was doing other things. If anybody has any requests, though, I'm more than happy to take a look at some of these afterwards or answer any questions. These are the ones that I successfully solved. There's a few others I could talk to if people have specific questions about them. But let's take a look at these real quick. So, oh no, it is not. Okay, let's try this again. The software is a little more finicky than I'd like. But so we have several binaries here, and let's take a quick look at them. Again, if people have any questions or comments, the YouTube chat is probably one of the better ways to let me know. Otherwise, Slack is another method, and I believe I actually have IRC open this time. So any of those should be good. So let's take a look at one of these. As you can see, I spent the last part of the competition, I spent taking a look at Fagin, trying to get that to work, and did not quite manage to get it in time. I had a input that gave me partial control over EIP, but not full control, because it was basically I could write between, I think it was, I could write 3 nibbles into it, and I couldn't find a gadget in time and wasn't able to do it. And I didn't have the full work for being able to write all of it. I should have been able to, but I wasn't. If you're curious, Fagin was a Intel 4004 processor emulator. And there was a problem with how it handled writes to memory. So, the version is I looked at it, tried to land it, did not successfully land it, and had to finish the competition feeling sad about that. But let's take a look at some of these magic binaries. So these are in the style of the, here are a ton of binaries, write something to solve all of them. And if you do, you'll be able to get a flag out of it. And like I mentioned earlier, the previous year's version were all exploits. You try and exploit all of them. My understanding is that all of these were crack me's. Instead of having to exploit them all automatically, you had to supply an input that would solve one of them. One of the things that's interesting about that is it means that instead of having to do it live, I could pre-generate all the inputs. So with the exploits, I need to be able to do it relatively live, especially if I need a pointer leak or something. Whereas for crackmes, I could solve all 200, and even if it takes me, 10 minutes for each of them, 10 minutes for each of them probably isn't reasonable. But let's say a minute apiece. I'd be able to then throw all of them when I'm done because I have solutions. So today, we're going to take a look at these. So first off, this seems relatively straightforward. And I still have, I believe the rumor is that if I update, I thought if I updated this was gone, or it might just be in the current testing build this is gone. Anyway, so taking a look at this real quick, we're calling calloc to allocate a buffer. We're putzing the enter your code. We're flushing. We then call fgetS to read into our buffer. I assume this is a reasonable length, right? Yeah, so even though these are broken and I can't see what it actually should be, so for anybody who's watching, the issue here is that Binary.ninja sees, what is this? OX50 and says, oh, that's an offset because that's mapped into the binary. The OX50 address is mapped in. And it is not actually an offset. It's trying to be helpful. It's trying to fix things. It is failing. If you're using the, what is it? There's the developer branch and the release branch. On the release branch, it isn't there. But depending on exactly how we end up solving some of these, well, actually, let's do that real quick. Let's over to the release branch. We're going to update real quick here, and we should be able to see this perfectly fine and not have major issues, because I don't think I'm going to do anything super crazy with any of the API stuff. The biggest difference between the release and the development build is there's some API changes. There's a bunch of new features they're testing out. This is actually one of them, the type system. And unfortunately, in certain cases, it breaks. And there's a workaround that I can never quite remember when I'm on stream. It seems like when I get on stream and run into this is when I go, oh, I don't remember how to do that. But while we're waiting for this to up, of course, all I have to do is say something, and of course, we automatically get to where we were. So here we are in something that's a little bit easier to read. Oh, that's the big... Oh, no, they still have it. Okay. I was going to say, when I started using the developer build, it was because the low-level IL had just been introduced into it. But now it seems that's in the release build, too. So let's take a look at what this binary is doing. There's a decent chance that many of you took a look at this over the weekend. So we call calloc, we allocate 51 hex bytes, we then print out enter code, we flush, we call fgetS from standard in with 50 hex bytes. So we're going to read 50 hex bytes is what? 400 decimal bytes into some allocated buffer. And we're going to call this subroutine with it. Okay, that seems pretty straightforward. And it looks like they're going to, it says the sum is something. We're going to load the return into that. And okay, that seems straightforward. This is a little more complicated than I was expecting. Wow. That is quite the binary. So they took the 400 bytes we gave it, and they take it in here, and it passes through quite a few binaries, doesn't it? Like functions. Each of these functions looks like it's probably unique, isn't it? Okay, this should be interesting. So we have RDI, which was the first argument to this. Why is it? That's clearly not right. So this label is clearly wrong, and I'm not sure why it is. But so we have this. We're taking this, we put it into RBP. This is just wrong. Seems odd. No? Okay. So we're taking the first argument, only argument. We're saving it into RBP. We then take some space for our stack. We take the first byte out of it, and we call this function with it. We then take RBP plus... Is this not actually fixed in this version? Well, it's unfortunate. I could have sworn that this version was fixed. Will I be looking at any ponables on stream? Not unless there's anything in particular that people would like to see. Right now, my plan is to go through and solve just the crackmes, because I didn't get a chance to do them. If there are specific requests, I'm happy to take a look at it a little bit. But at least right now, the plan is to just go through and try and solve this. So, let's take a look at this real quick. So we have, what is this? So we take a byte, we try and read it. We take a... What are we doing here? So we take the output from that, we shift it right by 3, so we're dividing by 8. We put it into RBX. We call another function. We read a byte. We take the output of that, we add it, we shift it. So it's basically like a kind of like a CRC or something, right? We've got these functions. They're probably each getting called with a single byte of input, and they're probably So Brian's asking in the chat about Osno. So at least one of the bugs was there was just an undocumented menu option, let you write into the heap a bunch of bytes. I know I played with that for a little bit, but didn't actually get anywhere useful with it. But that, as far as I know, was the only bug. At least it's the only one that I've heard of. And if you had all the pieces put together, you'd be able to land it from that. It was actually, at least the way we were trying to do it, was very tricky. Okay, so going through this, it looks like this is definitely... So take the first byte, call the first function. Take the second byte, call the second function. And I go through this, I will probably see... How many bytes are we actually trying to read here? 2 D bytes, is that correct? I think it's 2 D bytes. Because of course I can't actually get that to do what I want it to do. But in any case, we're going to read 2 D bytes, which is +1, so 46 bytes, I guess. And it looks like every time they take the output from this function, they add it to, like, they have this running counter. They shift it by, they divide by 8, which makes sense, right? So they take in a byte, they shift by, when they shift by 3, they're making space for another byte of output or something. Okay, I guess I'll buy that that's a thing. Let's take a look at the first of these functions. So the first of these functions compares it to 64. If it is equal, we're going to put 6C into that. Otherwise, we're going to exit. We don't want to call exit. Calling exit would be bad. So presumably, each of these functions is basically comparing a byte at a time to some, like... Okay. So it's taking a byte at a time, it's comparing it, and as long as it matches, like, I don't think we actually care as long as the program doesn't exit, because each of these If the comparison fails, we'll exit. Okay, that's a thing. Let's give that a try real quick. So, if I do this, I should be able to GDB O. I believe OA is the one I was looking at. So, what's the best way to actually do this? You know what? We'll just break on exit. I believe the first one was 6.5, which is A, B, C, D, E. So E, continue, E, stuff. We called exit, and we called it from 9.4F, which, come on. We got to the second. So this is the first function. (9.4F), which, I mean, is completely right. Like, that's what I expect to see, except I was wrong about the byte. But in any case, that means that this, in fact, does work the way that I expect it to work. So, let's take a look at another one before we try and write any of this. So we have the first one here. We have a second one. And let's compare main. So those look actually identical. At offset 7b2, there's a function. This function also looks basically identical. So that's interesting. The offset, like the functions, are at the same location, even though some of the other stuff got moved around. And exactly the same thing, they're comparing a byte and doing stuff. So let's go about trying to rate this. So, where are we? We're going to go into Magic. We're going to write a solver from Binary.ninja import star. BV is equal to, I always forget this, and every single time I have to come in here and do it manually because I always forget. So, Python from, you know what, let's do this the other way. Python -I. No. Oh, I need to actually save it if I want to have anything, don't I? I can't type right now. So, we have this imported, and BV is equal to binary view, I think? That's a thing? Here, you know what? I'm going to go look this up. Binary. Now that I say this, I have code on here already that actually I can reference instead. So instead of doing this that way, I have, so if you want to take a look at this code that I'm looking at here, this was a little bit of stuff I threw together to try and test out Manticore. So specifically to try and, for a given binary, use Binary.ninja to find all the places where a allocation function was called, and then use Manticore to try and solve for an input that would make that allocation go into one of the various bin sizes when it was freed. So the code for this, finding all the allocations works fine. For the Manticore stuff was failing, and I didn't ever get around to actually fixing that yet. But this does very conveniently have the code I need to actually get it up and running. So I want a binary view type of elf. This is saying I want the elf parser, essentially. I want to open a file name. And we're going to wrap this in a function. Def solve bin file name. We're going to assert that there is a BV. Because under certain situations, like if I gave it an invalid file name, it's going to not do anything. And all this other stuff would cause exceptions later. Might as well just do it now. And then update, analysis, and wait. What this is going to do is this is going to run all the startup analysis stuff. So we have this. And let's return BV. Let's do this for testing. So we're going to run this again. I want to solve bin. You're going to work. You're not going to work. I do not get to be that lucky. So cd magic. Just take this one right here. So solve bin is not defined. Solve bin. Okay, I guess I did not properly save the input. So, it helps if I, Python does not have the vim commands. Okay, so that works. So, what are we doing here? So I want b.symbols, the thing, right? You have main, right? Yeah, we have a main symbol. Okay. So main is equal to bv.symbols main. We're going to fetch the function for main. Dir main. I want main dot. I thought this would work. Well, I could get the function directly from that, but I guess I can't. B functions? Oh, I want dot functions, duh. Okay, we're gonna do this the other way. We're gonna actually look at the documentation. Crazy talk, isn't it? Instead of just trying to stumble around in the binary console, I'm gonna actually look at some documentation. That's just crazy talk, isn't it? Okay, so I have a binary view. That's what I have returned to myself. I want the binary view. I want the actual stuff here. So how do I get a function? I want to get function at. So I want v.get function at dot address. So this should work. Get function at main address. What do I get for having differently named variables across them? So now I have a function. So with a function, I should be able to say, I want one of the calls which is not to something with a symbol. Is that going to work? So if I go back to b symbols, all of those subs don't get a symbol name because they're not real symbols. They're auto-generated symbols. So if I do, so I want to find the process function. So for I in main, print I. That's one basic block. Main. Thought there was a pretty easy way to go through this. So I want main. Yeah, I'll just do main.basic blocks. Let's let's assume that there's only going to be one basic block. Basic blocks 0. And I want the first one, and this is BB for basic block. Here, BB. Hello, CFI. Welcome to the chat. So for anybody who has joined since I started, right now we're trying to write a solution to magic, which is a set of crackmes. They gave you 200 binaries that each took an input. We're trying to solve all of them with some Binary.ninja scripting, because I did not get a chance to solve this during the competition because one of my teammates so rudely stalled a challenge. How dare he? So let's take a look at this real quick. So we have our basic block for the main function. I want to get for I in BB. Yeah, this is what I want. So we're looping through here, and we can iterate through a basic block, and each time it will give us the instructions. It's interesting that this is not doing what I wanted it to do, because what I was hoping it would do, that it would actually give me the name that it was using, but that'll work. So for ints in BB, if ints, what actually is I? So I doesn't have, So I is a tuple. It is there's a list. What's that list? There's a list, which is the mnemonic, and then a number. I'm not sure what the number is. So one thing that's worth noting is that this is different from development and release. Right now we're looking at release, and it works a little bit differently. The last time I looked at this was on development, and there have been some changes in how all this is handled since then. So we can work with this, though. So we want a call. So we want if ints 0, 0 is equal to a call, then we know it's a call. We want the next argument then, right? Or no, we want 2, the second argument. Print out ints 2. This should work. And for our testing, if name is main, solve bin magic dis that thing. So that's unfortunate. Did I go too fast again? Is the length in memory? That would make a lot of sense. Because a call was definitely 5 bytes. The complex LEA, I'll totally buy that that's length in bytes. So that is agenda, I guess it's agenda, commenting in the chat. Really? Well, now I'm all sorts of confused. Print ints. Why is that not working? Python solver. Yeah, that's that is indeed doing what I wanted it to do. Stop. What am I doing? Oh, I have caps lock on. Definitely the downside to using Vim is if you accidentally hit caps lock, it is incredibly confusing. What? Oh, or is this not actually a string? There we go. So, what's happening here is that what is being returned there, it looks like a string. It's actually an instruction. So if I did... Is that the right way to do it? No, I want... Nope. I don't think I've ever hit an F1 from a terminal and actually wanted help. I think that's what I want. Yeah. Except I don't want it on that, I want it on that. It's an operand. So that's why it was failing. But that's not important. What's important here is... What's this? Does that actually save? That's text? That may cause problems. Yeah, if you haven't used it before, the API for Binary.ninja is great. It's super useful. I'm thinking about this a little bit more, and I think what we're going to do here is we're going to write awful code to make this a little bit easier to iteratively go through this, which is basically, instead of doing things that way, we're going... Oh, no, go away. We're going to say... We're going to do things this way. And we can fix this later. So I want to do that. I should have a BV main main. I want main. How do I get the low level ones? Low level IL. There we go. What I'm hoping here is that this is a little bit easier to get to work with. Because every time I've done this in the past, I've used the low-level IL as opposed to the assembly, because, well, ever since they implemented it, because it's so much easier to work with. And hopefully I'm not lying to you all now. So like the difference is this is what it looks like in assembly. Their low-level IL looks like this, which looks almost like it's a little bit more readable. So it's also a lot easier to work with programmatically. At least that's the intention and how I've always found it. So we have this here. I don't remember if I have to go through the basic blocks or not. In any case, there's only going to be the one. So we're going to do the same thing here, except I want to do main LL, low level IL, and I want to use that instead, and I want to print out every instruction. What? So here are each of the instructions, and so what I want to do, what does an ints look like? So dir ints. I should be able to do ints dot function. What does that do? Oh, I want operation. And what I can do here is if ints dot operation is equal to low level IL operation LLIL call? I think this is what I want. Yeah, there we go. So ints call. Here we go. So I'm going to do call dot operands. Is that what I want? Yeah. There we go. And I want is that thing. And how do I get the actual integer value? O dot value. That looks right. Yeah, that's what I wanted. So basically what we've done here is we've gone through this function, and if it is a call instruction in the low-level IL, I want to get what we're trying to call. So I want to do call, what am I just said the words here. I want to get the what we're trying to call. So if it's a call, then target is int dot operands 0 dot value. This is getting the value of what it is. And now bv.symbols is a thing. Is there an easy way to do? Functions were declared to each of them, but symbols were not. So I should be able to say sims is bv.symbols.values. Sims 0. Sure, sims. Oh, so these are. No, that should work. So if I say that's what the symbol is, if we are calling a symbol, I want to ignore it because it's not a real thing, right? That's the way that should work. So sims 0 address. Yeah, there we go. If target in bv.symbols.values this isn't going to work quite the way I want it to. So I want symbol, we'll call it this way. Sim adders is equal to I dot address for I in bv, for I in bv.symbols.values. So for every value in the symbols, we want to get what the address is and create an array of those. So if target is in sim adders, if not target in, I want to know what this address is. Oh, helps if I can type right. If it is not in there, what? There we go. So we only have the one thing, and let's open this one up and make sure we're correct. It was FEC. Yep, it's this one right here. So the only call here we have is to AEO, which is, in fact, the address we're getting. Awesome. So we want to then have this proc func is target. So we should now have a function to process. So func is bv.get function at. We have an address here, which is proc func. Basically, so what we're saying is if you have a symbol for this function in main, we don't care about it, which isn't necessarily true, but I think it's a safe assumption. Basically, it's something that isn't out of libc. That's what we're going to process. So we have this here. One thing that is interesting, I don't know if we need to do it. Let's give this a try and see if we need to. We might have to handle cases where the input buffer is not processed linearly. So not one byte at a time, like process byte 0, then byte 1, then byte 2. We might need to handle the case where it's processing them out of order, but at least the first pass, so none of the 3 binaries we've looked at manually needed to do that. So hopefully we're lucky here. So we have function. We're going to do the exact same thing. Func ll is a func.low level il. Is there going to be more than one basic block? I think there's only the one basic block, right? I guess there's several, but we don't care about the ones down here very much. Oh, Oh ho ho ho. Oh, I don't think it matters, right? So if RBX is equal to this, then we're going to go over here. Otherwise, we're going to call exit again. But like it has to, right? So I don't think we actually get to control this. Oh no. So if RBX is equal to that, then we go over here. Otherwise, we don't. And I mean, it's not like we control this value at all. It's a constant. We either exit or it's a constant. So I think we're good here. At least I'm guessing we are. So let's go about actually processing this. So we're going to do the naive approach here, the super naive approach, which is we're going to go through the first basic block, and we're going to take each function. So basic block is equal to a funcll dot basic blocks 0. And what are we going to do? So we're going to say for instruction in basic block, exact same thing. If it's a call, we need to process that call. So we're going to do, again, the same thing. Pfunc is bv.get function at target. Pfuncll is the function is the p function dot low level il. So we for each of these functions, let's do this real quick. Print checking sub %x %target. They're going to print it out. We're also going to build up a buffer for this. So out is equal to string. We have our low-level function. All we care about is going to be the first block, right? So all we care about is this right here. So again, same. bb2 is pfuncll dot basic blocks 0. For ints in basic block 2, print ints, and then we're going to break. Because I just want to test this real quick and see where we are. Okay, so that's a thing. One thing that's worth noting here is we're setting ints twice. I don't think it matters given that how we're doing things, but we should do it the right way. So this is a low-level IL instruction. We have a lot of operands. So inst.operation is a if. The operands are tons of them. I guess not true. So the only operand is that we have that. What's the source operand? Okay, I can do that. In stock condition and your C. And I want the right side of it, right? Yeah, there we go. So out plus equal ints 2. Like we're really assuming that the first basic block is only this one if statement. If it isn't, we're going to break hard, which is good, right? We don't want to do a ton of processing that is going to fail. Print out. So if this works, we should see a lowercase e. Oh, right. We have a lowercase e, look at that. And if instead of breaking, we let it process the entire thing, we get experience this AF. Okay. And if we do magic disp FA, that's what we're looking at? No. FEC. And we want this thing right here. Doop. Sum is 13. I think it sounds right. So we should be able to do that. Let's get rid of this code. We don't need to print that out. We will do def solve bin file name, print %s, comma %s, going to be file name, comma out. I did it again. The escape key is small on this keyboard because I'm using a laptop for this. So it's a little bit smaller than I would like. And it's right beside the F1 key, and sometimes I miss slightly and my finger rolls over and hits the F1. But let us solve bin file name. Yep. I gotta remember if I have to do them in order like this or not. What? Am I bad at typing? Solve bin. Oh, solve. Yes, I am bad at typing is the problem. There we go. So we have let's do it that way. And then I want to import os.lister magic dist. There we go. So we want to do for file name in os.listdir magic dist. Not sure if we actually have to import OS or if Binary.ninja does it for us. I suspect this is the ... and ... but what? If BV is none, how are we getting there? Oh. Duh. Ow. I want to solve magic dist slash plus. So while we're watching this, hello Gecko, welcome to the chat. What we're doing here is solving the magic challenges from Defcon quals last week, or last night, yesterday, the weekend. It was a long weekend, so I apologize if my speaking is not as eloquent as it sometimes is. But yeah, so what we did here is we just wrote a little bit of Binary.ninja to go through and solve these. I suspect that if this is a single block of text, that if we line it all up correctly, it would be something to read. But yeah, that's all it is. We basically just took a binary. So while this is running, we took a binary. We get the main function. We want to find the calls in that main function. There should hopefully only be one, but find the call which is not to a symbol. So it's not to something out of libc that they were able to identify as a symbol. Then take that function, because that's the function that has all of these process functions. Get the low-level IL for that. We're going to loop through the first basic block, because the first one is the only one we care about. And basically take the calls out of that. We then know that the first instruction that out of each of those functions is going to be an if. So we're going to get what it's comparing it to and dump it out. As we can see, it looks like it works just fine. I suspect it works well enough to throw at the server, but the servers are all down. So I think at this point, this is about all that I intended to do right now. Trying to think of what else we can do, because unfortunately all the challenges are down too, as far as I'm aware, and the magic one is the only one that I had a solution for. Oh, I know what I'm going to do here. So the way we solved it was we used Binary.ninja and we solved it statically. We said that we're going to go through and take a look at the comparison. One thing that I've been pushing the past couple weeks, or past week, I guess, is Manticore, which is a symbolic execution framework from Trailbits. So we have the concrete solutions. We looked at the comparisons and we found out what it is. Let's try the other way. So instead of doing this concrete comparison, let's see if we can symbolically solve to do this. So how would we do that? So we know that we have a main function in all of these. And we know that if we fail any of these conditions, we're going to call exit. So let's think about this for a second. If we call exit, we fail. All we need to do is we need to get to the exit condition. Well, the non-exit condition. So basically what I want to do is I want to say, I want to go back to assembly. I want to get to here. If I can get here, then we succeeded and we got where I want to be. Right? That sounds right. So how would we do that? So let's copy a single one of these here for some testing. So we had that and that works. While we're here, let's take a look at the other side of this, which was... So this was where I took a look at trying to solve this. Oh, that's not what I wanted. Let's go here. So I want to do vim imcore. So I want to use this as a template. From Manticore, import Manticore. And what do I need to do for this? So I can go im is equal to Manticore, file name. File name is equal to test. The reason we're doing this is just to make it easier later to turn it into a function and loop through it. We don't have a seed for it, but we want to do a hook. And because it is pi, so I get this wrong, aren't I? No, yeah. I always mix up the is it file or binary because Ropgadget is one of them. Checksec is the other. I never remember which one's which. But so it is full railrow and pi is enabled. So what we have to do is we have to set our hook at this plus the address we want to call. And basically what that is when you're debugging with GDB, I know does this. I don't know about, and whatever Manticore is using under the hood clearly does the same thing. To make it easier to debug, they put the pi segments at the same address every time. And it's just this constant value that we can use. So we're setting this here, and then I want the return from main. So I want to set it at 7b7. And I think this is going to work. So I want to I'm going to declare a function, which is that, ret hook. We accept a state. CPU is state.cpu. How do I actually do this? Let's go to the documentation. So Manticore. So basically all I need to do is I need to get the input that actually gets us here. And when they did it, I guess that's one way to do it, is I could break in at just before each of these and solve for how to get there. But that seems messy. I guess that is one way to do it. Can I just solve for it all at once? Like, I want to say the only input I want is what gets me here. And so they hook standard in by default, and they write it in like that. So what's the best way to do this? Oh, no, I want this one. Wrong link. How do I do this? So I have Manticore. I have... Sure, let's go with this. So there's a way to set the concrete data. But if I set that, it becomes concrete data. What I want to do is I want to solve for standard in. I guess one way I can do this is I can say that here at 7AF, I want to mark it as symbolic data. How do I do that again? I want... Where is it? Not this. API reference. Here we go. So I want to create a new symbolic buffer, which is RDI. Buff is state.new symbolic buffer. The sizes change? There's always 51 bytes. Sure, let's do it this way. Because everyone that we've looked at, I think, was 51 bytes they allocated. So we want credit. It should be a C string, but I don't think we care. It returns the expression, returning the buffer. However, we still need to write it into memory in order for it to be useful. So to do that, we're going to come in here. How do we do that again? So cpu.rdi is equal to buff. It's a thing. It sounds like a thing. I'm going to change RDI from what it is to that, and I want to be at AF. And im.context buff is a thing. Im.context buff is buff. And then end, which is at 77. And I want to do I want to do a state. I don't want to call it. So they were talking about this in the chat today, that because I brought up this, I don't know if it's actually a bug or not, but they've added it we need to... I want a solution for it now. How do I do that? So they responded. Have they responded to this yet? Hmm. So I guess the good news is that by doing this, what does this do? So the one major downside is that this is going to be basically orders of magnitude slower. If you remember the like dynamic-ish version of it, it took what, a few seconds. This is going to take probably several minutes for each of them. Oh, nope. It was in fact not able to solve anything. Memory exception at PC. What if I just naively do it? So rather than writing a script to do stuff, just go. And again, so the downside here, so what we're doing here is Manticore is a symbolic execution framework, and nope, apparently this is just not going to work. So I think I actually read in their chat that they were on the list of things where to fix it so that this actually worked. But it looks like what we're having is we're basically just running into bugs in this thing. But what it should be doing, if it was working properly, is we would be able to say, instead of going through and finding the concrete comparisons, we can use symbolic execution and, in particular, SMT solving. So that's, what does the S stand for? Something modulo theorem. It's some complicated math stuff that basically means I can give an equation, which is in the form of a set of constraints, and a SMT solver can efficiently find an answer to it. My understanding is that that is at the most common use for Anger is to do that. Anger has a ton of features, which is why I'm saying my understanding, that you can use it to, here's a binary, give me inputs that can be down different paths. I don't have it set up in this environment, or I'd try and demonstrate that too. But the idea would be that we should be able to take this binary, the test binary, plug it into one of these symbolic execution frameworks, let it run for a minute or two, or however long it takes, and it will spit out the input that gets us down the path we want to go down. There's a whole bunch of other things you can do with it. For example, I was talking earlier when I was showing some of this stuff off. One of the things I wanted to do with it was to solve for if malloc in a given binary could return each of the fast bin sizes. So if you've been watching these for a while, or you do DL malloc exploitation, yes, SMT and SAT. So SMT is a specific type of solving. So Animoweni in the chat asks about this. So SAT solving is the class of problems. You set up a set of constraints with and you use a SAT solver. I believe SMT is the language most of those process over, or SMT is the theorem that they use to actually solve them. But the short version is, so Manticore is Trailbits' version of Anger, more or less. Except, at least my experience with Anger is that Anger is solves a ton of problems in a ton of different ways, and at least my impression of Manticore is that the intention is they're not really going to solve any problems, they're going to give you the tools to do it yourself. Which is something that I've wanted out of this kind of stuff for a while, which is why I've been playing with it on stream. But as we can see, it failed hard, and I can't actually show anything. If it worked, though, I should be able to pretty easily set up and say, give me a input, which would get me to this thing, some point in the binary, without crashing. Unfortunately, clearly it does not, and for a product that has been public, or for a piece of software that has been public for a grand total of about a week and 6 hours, I'm not that surprised that it failed on a binary like this, given that, as David mentioned in the chat, there's a decent chance there were some things done with it intentionally to mess with it. Because given that it was for, a major CTF, they would want to take steps to make sure that I can't just take anger with default options and have it just work. Because that makes for a lame challenge. Whereas if you know what you're doing and try and do something, that's a little more interesting. So I guess that's my little bit of a spiel about it. So Manticore is, I guess I could call it a competitor to anger, is at least kind of the intention. Competitor is bad because I don't think neither Anger or Manticore is going to really make the people who develop it that much money on its own. Anger being made by UCSB and Shellfish, Manticore being made by Trail of Bits. But they're both open source. You can mess with them, you can learn them. My hope is that Manticore is easier for me to learn, given that it's basically just a bunch of Python bindings. So I'm trying to pick it up. I've been working on it for a little while now. Ran into a ton of issues, so that's unfortunate. Hopefully they get fixed, or I can track them down more and try and fix them myself. So I think it's about all that I have this week as far as stuff goes. One thing that is of note is that unlike almost all of the other streams, this weekend there is not another event. This weekend there is literally nothing scheduled. So I think this weekend I'm going to sit around and fix up the apartment and get things cleaned up, because I kind of let things kind of... I actually can't give you a link to the challenge right now, because their servers are currently down. So the context was, for the challenges, you were given 200 binaries that if you gave it the proper key, it would do something. And you had to create keys for all 200 of them. So you had to use some sort of an automated method. And then when you talk to the server, it would actually tell you which ones you needed to give it keys for. So I was just going through the easiest of those. It was called Magic. At some point, the binaries will become available again. Right now, they're not. The Legit BS guys took down their servers pretty soon after the competition. And if you didn't get it prior to that, you're not getting it until they eventually come up or people mirror them. When I do find a link to them, I will definitely post it out on Twitter. But at least for now, unfortunately, I cannot share a link to them because I don't know where one is. So, yeah, I think it's about all that I have for this week. Like I said, there's nothing coming up this weekend. I'm probably just going to fix things up around here. I've kind of been slacking with all the CTFs in April. There's actually not any major CTFs coming up for several weeks. I think the next thing that I'm going to... that is not... the next thing on CTF time that is not a local event is not till the 20th. So 3 weeks away. We'll see. It should be exciting. There's definitely a lot of things that I've been putting off to play CTF that I can now not put off and still play CTF when they're available. I suspect next week the topic is going to be going through some other challenges. What I'll probably try and do is get a hold of... what was the other one? So there was Magic, which was the easiest one, I believe. And then there was a next hardest challenge, which was the exact same type of thing. It was, here's 200 binaries, give me keys for each of them. For Adam Owaney in the chat, the one in Krakow, I believe, is run by Dragon Sector. They did their teaser a few weeks ago, and I would highly recommend doing it. I suspect it's going to be a ton of fun. The people who run it are great. Definitely do recommend. It's apparently at the Confidence conference. I have no idea what that is. All I know is that the Dragon Sector guys are running a CTF at it, and I suspect that's reason enough for me to go if it was local-ish. Considering it's a long plane flight away, I'm not going to be going. But if you go, hopefully it's fun. It sounds like it. Like a CTF run by Dragon Sector always sounds good to me. But like I said, that's all I've got for now. Wow, that is a very high weight for an in-person event. Like, that is a much higher weight than I was expecting. It's probably quite good then. But in any case, thanks everybody for tuning in. If you have any questions or comments, feel free to message me on Twitter or leave a comment or send me a message on Slack or any of the many methods of communication. When I get a hold of some links to this stuff, I'll make sure to tweet them out, especially with binaries. I think next week I'm going to try and do the exact same thing. Get one of the other challenges that were in the Crack Me's category and just solve it on stream. Although we'll see. Something may or may not come up between now and then, and we may have something more interesting to talk about. But thanks everybody, and I will see you all on Wednesday for hopefully finally finishing up PDF Crack. Thanks everybody.